Today I will be doing problem number 11 from chapter 2. The problem says a particle starts from rest and accelerates as shown in figure P211, which is right here. Determine A, the particle speed at t equals 10 seconds and at t equals 20 seconds. To get the particle speed at t equals 10 seconds, we know that the time is t equals 10 seconds. We also know that the acceleration is 2 meters per second squared because it is constant at 2 as shown in the graph. We also know the initial velocity is 0 because the particle starts from rest. From that we can do Vf equals V initial plus A times change in t. Plugging in values we get Vf equals 0 plus 2 meters per second squared times 10 seconds. Vf equals 20 meters per second. This is the speed at t equals 10 seconds. Now to get the speed at t equals 20 seconds, we know that the acceleration is -3 meters per second squared because it is constant from 15 to 20 seconds. And we know that the initial velocity is 20 meters per second because it accelerated to 20 meters per second and then the acceleration became 0. So the velocity stayed at 20 meters per second at 15 seconds. So we have our V initial, our acceleration, and our time. So we can use the same formula. And our V initial will be the time we found at 10 seconds because the acceleration goes to 0. Our acceleration will be -3 meters per second squared. And our time will be 5 seconds because we chose to do the time from 15 to 20. This gives us final velocity at 20 seconds of 5 meters per second. Now to do B, we have to find the distance traveled in the first 20 seconds. So from the period 0 to 10 seconds, the car is traveling from an initial velocity of 0 meters per second, or the particle is traveling from an initial velocity of 0 meters per second to a final velocity of 20 meters per second, and the time is 10 seconds. So for the first 10 seconds we can use change in x equals 1/2 V initial plus Vf times change in t. This gives us 1/2 times 0 meters per second because we started from rest plus 20 meters per second, which we found in part A of the problem, times 10 seconds because we are going from 0 to 10 seconds, which equals 100 meters. Now from 10 to 15 seconds, we are going at a constant velocity, so we can use the simple equation change of x equals v times change in t. Our constant velocity is 20 meters per second. And our time will be 5 seconds because we are going from 10 to 15 seconds, which gives us once again 100 meters. So we are now at a total of 200 meters. And now from 15 to 20 seconds, we know that our initial speed is 20 meters per second, and our final speed is 5 meters per second because we found it in part A. We found the speed at 20 seconds, and we know our time is 5 seconds, so we can use the equation that we used above. Change of x equals 1/2 v initial plus vf times change in t, which equals 1/2 times 20 meters per second plus 5 meters per second times 5 seconds, because we are going from 15 to 20 seconds, which equals 62.5 meters. Now we want a total of 100 meters plus 100 meters plus 62.5 meters to give us a total of 262.5 meters, which we will round to 262 meters. And that is it.